Good morning, students. 12th English Physics, current electricity, continue. Okay, we will see some more questions about circuits. Okay, see, you are given one circuit as shown in figure. You are given four resistors R1, R2, R3 and R4. R1 is equal to 400 ohm, R3 100 ohm, R4 500 ohm, RE is question mark. This battery is of 18 volt. One data extra is given, that is potential difference across R4 is 5 volt. Yes, potential difference across R4 is 5 volt. You have to find what is resistor R2. So see, first of all, as you are given some data about R4, so we will start from that. Okay, before R4. Chalo. R4 resistance you are given. R4 is equal to 500 ohm. You are given potential difference between two ends of resistor, that is V is equal to 5 ohm. So you can easily find what is current flowing from, this resistor R4. That is, I can say this I4 for example. Okay, so yes, I4 is equal to V upon R4. Okay, V upon R4. Yes. So I4 is equal to, it is V upon R4 is equal to, what is V? It is 5. R4 500. So you can easily say it is 1 upon 100 ampere. So current flowing from this resistor R4 is 1 upon 100 ampere. Now as this R3 and R4, they both are connected in series connection. Yes, current flowing from this, it is also I4 because current in this branch in series connection is same. Yes or no? So yes, if I give name in this circuit, that is AB. Okay, so current flowing from AB. Current flowing from AB, that is 1 upon 100 ampere. Okay, what is effective resistance between A and B? It is 100 plus 500. Okay, what is effective resistance between A and B? It is 100 plus 500 means it is 600 ohm. So what is potential difference between A and B? So yes, potential difference between A and B, B is equal to, it is, you can say it is I into R. So yes, it is I4 into R into because in this whole branch current flowing is I4. Okay, so yes, I4, what is I4? Yes, it is 1 upon 100 into RAB, it is 600. So this 200 cut means it is 6 volt. So see, it is a potential difference between 2 points A and B is 6 volt. Potential difference between 2 points A and B is 6 volt. So see, hello. These two are in parallel connection. So also potential difference between these two ends. Potential difference between these two ends. It is also 6 volt. It is also 6 volt. Now this battery is of 18 volt. If potential difference across these two ends is 6 volt, then obviously potential difference across these two ends, it would be 12 volt. It would be 12 volt. So it is 12 plus 6 is equal to 18. 12 plus 6 is equal to 18. Yes, it is possible when you have cell of negligible internal resistance. Okay, so yes, potential difference between two ends of resistor R1. Potential difference between two ends of resistor R1 is 12 volt. Now, why you have to find this 12 volt? You have to find resistance. And to find resistance, you must know V and I both. V and I both. You know what is potential difference between two ends of resistor R2, but you do not know what is current flowing from R2. So to find current flowing from R2, first of all you have to find what is current flowing from this resistor R1, that is I1. Okay. For resistor R1, resistor R1 is equal to, it is 400 ohm. it is 400 ohm. Potential difference between first, that is 12 volt. So yes, we can find that I1 is equal to V1 upon L. It is 12 divided by 400. Yes, it is 12 divided by 400. Okay, so it is 4 into 3. So it is 3 divided by 100 ampere. It is 3 divided by 100 ampere. Current flowing from this. Current flowing from this. Yes. Now see here at this point. At this point, if I give this point name C. Okay, at point C. At point C, you can apply Kirchhoff's junction rule, or you can say current rule. Okay, you see, out of this I1 current, here current flowing is I4, and here I can say it is I2. So if I apply at point C junction rule, then I can write that I1 is equal to, at this point, I1 is equal to I4 plus I2. I4 plus I2. So therefore, I2 is equal to I1 minus I4. So where is I1? It is 3 upon 100 minus, where is I4? I4, yes, there is I4, 1 upon 100. So obviously it is 2 divided by 100. Yes, it is 2 divided by 100. Simple. So yes, it is 2 divided by 100 ampere. Now we know, okay, what is current flowing from this resistor R2? I2, 2 divided by 100. We know potential difference between two ends of resistor R2. It is 16. Okay, it is 6 volt. Okay, V is equal to, it is 6 volt, and I2 is equal to, it is, yes, I2 is equal to, it is 2 divided by 100 ampere. So yes, you can easily find R. Okay, R2 is equal to, it is V upon I2. So V, it is 6 divided by 2 divided by 100. So is equal to, it is 600 divided by 2 is equal to, it is 300. It is your answer. Okay, so yes, it is one question based on, yes, Kirchhoff's law as well as series and parallel connections of resistor. Clear about this? Okay, so yes, it is one easy question, I think, but yes, you have to think. Okay, yes, okay, chalo. Now next question, but first of all let me check, is it visible or not? Yes, it is visible. Okay, chalo, to bachi next question. Again, you are given one circuit. Your question is, the current in 10 ohm resistor is, the current in 10 ohm resistor is blank. That is your question. Okay, you have to find what is current flowing from 10 ohm resistor. So see, actually circuit 5 volt battery, internal resistance 2 ohm, 2 volt battery, internal resistance 1 ohm. Yes, I can write this 2 ohm like this. K is internal resistance, it is 2 ohm. I can write this internal resistance like this. K is internal resistance is 1 ohm. Okay, now see, as you are given two cells, see, whenever you apply Kirchhoff's rule, you have to assume that current is flowing in this direction. Okay, for example, I am assuming that current coming outside from positive terminal of this 5 volt cell is I. So in this branch it is I1, in this branch it is I minus I1. I minus I1. From here it is I1. So again here it is I. So it is current distribution. Yes, it is current distribution. Now you have to find what is current flowing from resistance 10 ohm. Means you have to find I1. And in which direction? Hello. This direction I have assumed. Okay, it may be or may not be right. Okay, so we have to check. Yes, we will apply Kirchhoff's law. First of all, I am taking this loop. Okay, I will give some name, that is it is P1, P2. So it is Q, R, S, T. Okay, so first of all, I am taking loop R, P2, P1, Q. R, P2, P1, In this loop, you are starting from R, so it is real. No resistor here. In this case, it is minus 10 I1. Then here it is minus 2 I. Then here it is plus 5 is equal to it is VR. So VR cut. Simple. So you can easily write 10 I1 minus 2I is plus 2I is equal to 5. Equation number 1. Yes, equation number 1. Any doubt? Hello? Any doubt? Okay. Now second loop. You can consider any loop. Okay, actually. Yes, you can consider any loop. Okay. So yes, now second loop I will consider this side. That is S P2 P1 T. S P2 P1 T. Vs. So it is minus 10 I1. Then in this direction, it is in opposite direction. So it is plus 1 I minus I1. Then here it is positive to negative, which is minus 2. Again at S, so it is Vs cut. So minus 10 I1 plus I minus I1 minus 2 is equal to 0. Minus 10 I1 minus I1, so it is minus 11 I1 plus I is equal to 2. Equation number 2. Any doubt? Okay. Yes. So now, if I multiply this equation by 2, then what happens? Minus 22 I1 plus 2I is equal to 4. Equation number 3. And now I will see. You have to find I1, so you have to eliminate I. Here it is 2I, so you have to take subtraction. Okay, it is 10 I1 plus 2I is equal to 5. And if you are taking subtraction, then it is minus 22 minus 10. So this minus 32 I1. Okay, this is equal to it is 0. Okay, and is equal to 4 minus 5 means it is minus 1. 4 minus 5 means it is minus 1. Any doubt? Okay, so minus cancel out. So I1 is equal to 1 divided by 30. I1 is equal to it is 1 divided by 32. And now we have to find what is 1 divided by 32. 1 divided by 32. 1 divided by 32. Yes, it is 0.032. Yes, it is 0.03. It is 0.03. 0.032 ampere. And see, as your answer is plus. What is value of I1? It is plus. What is value of I1? It is plus. Means this current distribution that you have assumed, that I have assumed is right. Okay. Means yes, this current I1 which is flowing 0.032, it is from P2 to P1. Means in this direction your current distribution is right. If in case I1 is equal to minus 1 upon 32 or your answer comes minus, then you have to say, okay, yes, the direction I have assumed is opposite. Is not wrong, okay, it's opposite. Clear about this? So yes, if your current is in negative, then it does not mean that you are wrong. But direction you have considered, direction you have assumed is opposite. Clear about this? So yes, it is one question which is again based on Kirchhoff's law. We will see some more questions, but first of all, write down from board. Okay, now next question. See, you are given one circuit having a battery of 30 watt resistor, 10 kilo ohm, 10 kilo ohm, 10 kilo ohm, and it is one diode. Yes, it is one diode. Yes, characteristics of diode, two characteristics actually, forward bias characteristics and reverse bias characteristics. If it is diode, okay, and it is connected with higher potential, it is connected with lower potential, or you can say it is a positive terminal, it is a negative terminal, then this diode is said to be in forward bias condition. And in forward bias condition of diode, okay, resistance ideal, okay, if we are thinking about ideal diode, okay, ideal PN junction diode, then resistance in forward bias condition is 0. Similarly, if you are given diode, lower potential, here it is higher potential, which is negative or it is positive, then this diode is said to be in reverse bias condition. And in reverse bias condition, resistance of diode is infinite. Yes, it is infinite. So from chapter 14, okay, that is semiconductors, you have to remember these 2 points. So what about forward bias condition? What about reverse bias condition? In forward bias condition, resistance of diode nearly 0. In reverse bias condition, resistance of ideal diode is infinite. Okay. Okay. Infinite means no current is flowing. Yes, here current will flow. Here current flowing will be. Okay. So forward bias condition, it will behave as pure conductor. Okay. So yes, here this diode, see, it is its PN. It is connected with this positive terminal. So this diode is in forward bias condition. Yes, it is in forward bias condition. Means no resistance. And no resistance means you can directly draw this figure as like this. Okay. Yes, here it is D. Here it is B. A, B. It is 10 kilo ohm. It is 10 kilo ohm, and as this diode is in forward bias condition, its resistance is 0. You can draw, or you can say this straight, a conductor. Okay, so you can draw the figure like this. It is another resistance of 10 kilo ohm. Clear? So see, it is simple. It is 2 resistors, 10 kilo ohm and 10 kilo ohm. They are in, that is 30 watt. These 2 resistors, they are in parallel connection. In parallel connection, so their resistance is 5 kilo ohm. Now this 10 kilo ohm and 5 kilo ohm, they are in series connection. So 10 kilo ohm plus 5 kilo ohm, because they are in series connection. So their equivalent resistance is 15 kilo ohm. Yes or no? And yes, and potential difference is it is 30 watt. Potential difference is it is 30 watt. Then how to find current? Then how to find current? Okay, yes, current you can find simply. Okay, hello, yes, you can find total current. Okay, how to find that total current? Okay, so yes, I is equal to, it is V upon R. I is equal to, it is V upon R. Wait a minute. Okay, wait a minute. So if you use equation I is equal to V upon R, what is potential difference? It is 30. Total resistance is 15 ohms. It is 15 into 10 raised to 3. So 15 into 2. So you can say it is 2 into 10 raised to minus 3 ampere. And so yes, current flowing from this. It is here. It is I. So yes, you can find what is potential difference between this 10 kilo ohm. Okay, potential difference between its two ends. So potential difference V is equal to, it is I1. What is current flowing from this? It is 2 into 10 raised to minus 3. Its resistance is 10 kilo ohm. It's 10 into 10 raised to 3. So this 10 raised to minus 3, 10 raised to 3 that. So it is 20 watt. Means potential difference between these two ends. Is 20 watt. So obviously, if battery is of 30 watt, what is potential difference between A and B? So yes, potential difference between A and B is equal to 30 minus 20, that is 10 watt. That is 10 watt. Simple. Okay? So potential difference between A and B, it is 10 watt. Clear about this? Okay. Next question. You are given Western bridge, but this Western bridge is with 2 diodes. Yes, you are given 2 diodes like this. Again diode. So yes, you must know what is forward bias condition and what is reverse bias condition. Yes, forward bias condition and reverse bias condition. So see, first of all, we have to check that these two diodes are in which condition, means in which bias, forward or reverse. So see, this point is connected with higher potential. This point is connected with higher potential, or from this side you can also see, okay, they are connected with lower potential. So this both diode, they are in reverse bias condition. And in reverse bias condition, as resistance is infinite, current is not flowing from these two branches. Yes, current is not flowing from these two branches. So I can draw this figure as it is resistor, it is battery. Yes, it is going like this. Then yes, current is not flowing in this branch, so current is flowing in this branch. From this, current is not flowing in this branch, means it will be like this. Then it is like this. Then yes, this point is here and it's like this. Okay, it is of 10 ohm, it is 5 ohm, it is 10 ohm. Here it is 9 volt and here it is 5 ohm. Simple. Yes, simple. Clear? Hello? Okay, so yes, here it is your question. Okay, yes, what is current flowing from this circuit, or what is current flowing from this battery? So total resistance, 1, 2, 3, 4, there is series connection. So 5 plus 10, 15 plus 5, that is plus 5, that is yes, 20 plus 10, it is 30. It is 30. So current I is equal to, it is 9 by 30. Current I is equal to, it is 9 by 30. So I is equal to, it is 9. So it is 3 into 3. So it is 3 by 10, which is 0.3. Yes, I is equal to, it is 0.3 ampere. Means current flowing from this battery, I is equal to, it is 0.3 ampere. Clear? Okay. Last question. Not last question of this chapter, okay, but for today, okay, last question, that is current and potential difference between P and Q. You have to find what is current and potential difference between these points P and Q. See, as this resistor is connected between P and Q, yes, you can find what is potential difference between this resistor. So first of all, you have to find current. I is equal to, you have one equation, it is E equivalent on R plus R equivalent. From chapter 3, it is series connection of two cells. Yes, it is series connection of two cells. It is series connection of two cells. So see how to find E equivalent. These two cells, yes, they are in series connection, but they are in opposing condition. Yes, opposing condition. There are two condition of series connection of cell. Helping condition and opposing condition. In helping condition, it is called helping condition. Okay, but if you are given like this, it is called opposing condition, or like this, see, minus plus, plus minus, which is called opposing condition. And in opposing condition, if you are taking one EMF positive, then another you have to take negative. For example, if I am taking this 8 volt positive, then this 4 volt as negative. 8 minus 4. R means this external resistance 9. Resistance always negative. So R equivalent means it is R1 plus R2. Or I can write this equation as P1 minus T2 upon R plus R1 plus R2. So I is equal to 8 minus 4 upon 9 plus 1 plus 2. And yes, it is 9 plus 1 plus 2. Okay. 8 minus 4, it is 4. 9 and 1, 10, 12. So it is 12. So it is 1 by 3 ampere. Yes, I is equal to 1.1 by 3 ampere. So potential difference between not A and B, it is P and Q. V is equal to, it is I. So I 1 by 3. What is external resistance? It is 9. So is equal to, it is 3. Is equal to, it is 3 volt. So yes, potential difference between P and Q, it is 3 volt. You have to apply series connection of cells. Clear? Okay, so I think this is it for today. Next questions we will see in next lecture. Okay.